TT01. Okay, Nguyễn Khoa Bách, are you here?
Yes, sir.
Tiến Dũng,
Yes, sir.
Đoàn Dũng,
Yes, sir.
Việt Dũng,
Yes, sir.
Đình Duy,
Yes, sir.
Thanh Hải,
Yes, sir.
Vĩnh Hảo,
I'm here, sir.
Minh Hoàng,
I'm here, sir.
Trần Hoàng,
I'm here.
Quách Gia Hưng,
Đâu gì đâu, không vậy. Yes, sir.
Minh Trang Quang Huy,
Yes, sir.
Gia Huy, Quốc Huy,
Yes, sir.
Bảo Khang,
Yes, sir.
Huy Khang,
Yes, sir.
Quốc Khang,
Yes, sir.
Nguyễn Khiêm,
I'm here, sir.
Anh Khoa,
Yes, sir.
Minh Khôi,
Yes, sir.
Đức Kiên,
I'm here, sir.
Hoàng Lâm,
I'm here, sir.
Quang Lộc,
I'm here, sir.
Tấn Lộc,
I'm here, sir.
Thành Lộc,
I'm here, sir.
Lê Minh,
I'm here, sir.
Quang Minh, Vũ Quang Minh, Hạo Nam,
I'm here, sir.
Thanh Nghĩa,
Yes, sir.
Hiếu Nhân,
Yes, sir.
Trí Quân, Trí Quân, về mùa này share stream. Okay. Trí Quân, are you here?
Yes, I'm here, sir.
Okay. Anh Tài,
Yes, I'm here.
Huỳnh Ngọc Tân,
Yes, sir.
Quốc Thắng,
Yes, sir.
Bá Thành,
Yes, sir.
Văn Thịnh,
Yes, sir.
Tân Thịnh,
Yes, sir.
Quốc Thống,
Yes, sir.
Đức Toàn,
Yes, sir.
Lê Trung,
Yes, sir.
Minh Trường, Minh Trường, are you here? Thanh Tùng,
Yes, sir. Yes, sir.
Minh Trường, Tùng, okay. Hoàng Việt,
Yes, sir.
Lê Quang Vinh,
Yes, sir.
Anh Đạt,
Yes, I'm here.
Hồng Đức, Hồng Đức, are you here?
I'm here, sir.
Yeah. Vũ Quang Minh,
Yes, sir.
okay.
Dạ, trường tiểu học gì ạ?
Trần Anh Gia Huy,
Yeah, yes. Late.
okay. Yeah.
Dạ không, dạ của em là 0382 096. Dạ, dạ.
So before I go to the last chapter, let's review the previous, okay, about the interrupt and handle. And yeah, for your detail, I think that you should read the textbook. Okay, there's the full explanation for the interrupt and exception. In the slide, I just make a summary all the main point. Okay, if you need to have a full explanation, okay, let's go to the textbook. Where the textbook? Unless I show the textbook is here. Yeah, understanding Linux kernel. Yeah. Okay, and please open the chapter number 4. Where is the chapter number 4? This is chapter 3. Chapter 3. And yeah, chapter 4 is here. Interrupt and exception. Okay, and let's see. They explain the interrupt and what does mean the interrupt. Okay, interrupt, yeah, normally generated by the hardware circuits. Okay, the interrupt correspond with to the electrical signals. Is when we trigger the signal to the interrupt pin, and then the hardware, is mean the processor, will process the interrupt. And so the interrupt normally come from the I/O device. You see here, interrupt is used by the I/O device or the peripherals device. How about the exception? Exception, on the other hand, okay, come from the programming error. It means maybe by some error or by some user. If you want to have some exception, the programmer can make the programs and declare the exception, and the exception handled by the kernel of the system. It's different. The interrupt controlled by the hardware, and from the hardware they transfer the control to the software and to run the interrupt circuit routine. And in this slide, they also show you the type of the interrupt and exception. Okay, we have the maskable interrupt and non-maskable interrupt. Okay, maskable interrupt is mean just a normal interrupt. We can ignore, we can enable or disable. In this textbook, they use the word mask or unmask. Okay, it means enable and disable. Some interrupt cannot be ignored, such as some hardware failure or the reset signal. Also, there's a kind of non-maskable interrupt. And how about the exception? Exception, we have some type of exception for trap and airport. Yeah, okay. We have the explanation here. And you see that the interrupt, yeah, there's many explanation about the interrupt director table. You see, this is the interrupt director table I explained in the slide here. Yeah. Okay. Okay, continue. Yeah. Here, this is the slide show you the interrupt pin, and we have for the A086 processor, we have the pin INTR. This means the interrupt request. And when you make a signal from 0 to 1, okay, 0 to 1, this means the I/O device indicates or send a message interrupt request, and the processor will respond the interrupt request by the pin INTA. Okay, INTA, that is the interrupt acknowledge. And this pin have the low octave. Low octave, this means they respond by the 0 level. Okay, normally they are in the level 1. Go to the 0 is mean accept the interrupt. And after the CPU or the processor accept interrupt, the CPU will read the vector interrupt vector from the data pin. And how to configure the interrupt vector, I show you in the slide. Yeah, this slide. We can make the circuits, okay, and we use the chip LS244. This is a kind of the buffer chip, and we use as I explained here. Okay, this is the name gate enable buffer chip, and use this chip we can set up the interpreter very easy. You can connect the input data to the power or to the ground. To the ground means 0, to the power means 1. Okay, and when the enable signal active, the output signal will get the data from the input, and at that time the system, the CPU will read the data as an interpreter. Okay, and from the interpreter we can determine the interrupt circuit routing. How to do? I show you in this slide. Okay, from the interpreter, if you want to get the ISR means interrupt circuit routing. It's like address of the ISR, and we have to apply. We have to make the lookup in the interpreter table, and I explain here in two mode: real mode and protected mode. In the real mode, we use the interpreter table at the address range from 0 to 3FFH. Okay, so in the real mode, it's very easy. Interpreter occupy this address. It's a fixed location, and for each entry of the interpreter table is 4 byte long. 4 byte long, 2 byte for the offset address, 2 byte for the segment address, and we have two information: segment address and offset address. Then calculate the 20-bit address. How about the protected mode? In the protected mode, we have to find out the interrupt register table. However, this table can be located anywhere. How can we determine? We use this register, the IDPR register. This register will store the address of the first location of the register table, and by using this address, and then we can locate, we can know the location of the register table. And this is the each entry of the interpreter table is 8 byte long, 4 byte for the offset address and 2 byte for the segment address, and the last 2 byte for the other information, such as the privilege level and some security, some extra information. I will show you in the next part. Okay, before I go to the next part, let's review example. And this one, this example. In this example, I show you how to determine the address of the ISR. Okay, this is the interpreter table. All the value here, just the example. You can easy to change the value in this table. How to change? Very easy. You just apply the moving instruction. Just write assembly language, okay, for the moving data, and you can move some constant data to the location in the interpreter table. And how to determine the entry? If you have the interpreter, you just multiply by 4. Multiply by 4, and then you can have the address of the ISR in the location of the interpreter table. For example, the interpreter is 42 multiply by 4, you get 108. And where is the 108? 00100 here, and 102, 3, 4, 5, 6, 7, 8. Yeah, 108 is this location. Okay, and you see, we get first 2 bytes for the offset, and the next 2 bytes for the segment. Very easy. And you combine together segment address and offset address. Segment address is 4A 3C. Offset address is 33 2A. And then you have the final 20-bit address. You just add one more 0 and make a sum with the offset address, and you have 20-bit address. Let's check some notification. I don't know any notification. No. Okay. And here, this example show you how to modify the value in the interrupt vector table. It means all the value here. You can easy to modify. If you know the address of the ISR, if you know already, and you can copy to the location in the interrupt vector table. And how to know which location? Okay. If you have the interrupt vector 14, and you just multiply by 4, and you get the address. And from this address, you can copy the segment address of the ISR to here. You copy the offset address first, and then you copy the segment address. Okay. The 2 bytes for the offset address copy to the 0100 ISR location. Okay. And for the segment address, you copy to the 0102. The total 4 bytes. So I guess that you understand the example. Very easy. And you can do. You can check some problem in the final exam. There are some problem. Okay, some questions related to this example. Okay, and this slide show you some value for the interrupt vector table. Yeah, we define already the interrupt vector. Yeah, because some vector already defined by the system. Yeah, we have to follow. We must follow the rule there. The interrupt vector defined by the system, and for the user, you can use from the interrupt vector from 32 to 255. Okay. This slide show you the detailed information for interrupt register table. And we have the definition, the explanation here. Okay. This slide show you how to manage multiple interrupt pin. Because if you have many pin for the interrupt request, because for each device we have the interrupt pin for each device. But the x86 processor have only one pin. Interrupt request pin, they have only one. And we need the PIC chip to manage multiple interrupt request pin. Yeah, how to do? We connect the PIC, connect the interrupt pin to here, and we have A input for the PIC chip. From the A input, you can connect to the peripheral device. If you want to extend more than 8 devices, you can connect master and slave structure. Okay, you have one master and you can have many slave chip. How to connect together? How to connect? Here you see this is the pin. Okay, you connect the data, you connect the address, you connect read write, connect the interrupt pin, and this is the interrupt request for the 8 device. This is the cascade communication and how to use. Okay, I show you. Here, you download the A259 dataset. This is the A259 dataset, and you can easy to connect. Sorry. Okay, yeah, here. Yeah, how to connect together? You can connect by the cascade structure. This is the one master, two slave, and for one master you connect the cascade pin together. Cascade 0 connect to 0, 1 connect to the 1, 2 connect to the 1, 2. And for the interrupt request pin, you connect directly to the master chip. From the master chip, you have 8 interrupt request pin here, and you just select one to connect to the slave pin, slave chip. First of all, in this case, I select N number 3 and 3 connect to the interrupt request pin for the slave A chip. For the slave P chip, I connect here. M6, okay, the signal M6 connect to the interrupt pin. Okay. Any questions so far? I think connect together like this easy. You have the example already.
Easy. Ready? Okay.
And this is another example. You connect the A259 with the system A0AA system, and for the chip select, you can make some combination between the address, and you connect to the chip select. Okay. The next part is the exception handling and interrupt handling. Actually, they are similar. Okay. Normally, when the interrupt or exception happen, we have to save the state. Save the state. Okay. This one also is we save the content to the stack memory, and then we apply to get the address of the ISR, and then we run. Okay. After we run the ISR, then we have to restore the state. Okay, restore the state. Yeah, that's all the review for the chapter number 6. Okay. Now I can go to the chapter number 7. Okay, so before we go to the next chapter, please discuss together. Any questions? Any questions? Okay, so let's review e-learning website. If you have any questions, make your question in the classroom, class forum. Going to review the record video here. I make the folder, okay, to store all the recording video. Okay. Submit homework number 4. Already done. Some students have not submitted the homework. I will upload homework number 5. Yeah, but don't worry that homework number 5 is for your review. You don't need to submit. Okay, I add one more. Homework. Right? Okay. For your review, do not submit. Okay. Where is the homework? Okay, we done homework. See the homework number 5. Okay. Please, yeah, do the homework number 5 for your review. Okay. Yeah, homework number 5. Okay. Okay, so take a break 5 minutes. Okay, for you to read to review the homework number 5. This means the chapter 6. Any questions? Okay. Please discuss together. Okay, discuss together to review the homework number 5. Let I share the screen here. Okay, this is the chapter 7. Yeah. This chapter show you the memory management. Okay. This is very important for this topic related to the operating system and segmentation. Why we need the memory management. Okay. For memory management, we need the techniques segmentation and the techniques paging techniques. Okay, the segmentation techniques is used for the to manage for the multi-user program. Okay, because if you have some multi-program run at the same time or multi-user use the same system, we have to separate the memory location for each process. Okay, if you have multi-process, you need to have multi-memory location. And the segmentation is the technique to divide the memory location into some location. You see here, some location for the kernel, some location for the user process. Some location are free to use. Okay, it means no one use the location is free. Some location for the code and how to manage. They managed by the segment address. So for each location, we can get the first address of the location in the memories, and we store in the data segment in the segment register. This is the example. You see, for the assembly language, when you write some instruction and you mention about the address here only 16 bit, and this address is that is the offset address. Okay. For the segment address, we can get from the segment register. It means that for the programs, for the instruction, for the program, we don't care about the segment address. Okay, we only mention about the offset address, and we can easy to move this code to another location. Yeah, because when you move the code to run the code apply for the other location, we don't need to change the value here, and because we only can change the value of the segment register here. For example, at the first time, the segment register is 2100 point to here. Okay, 2100 here. This is our data segment. And after that, if we want to change, so 048 here is mean 0 mean this location, 4 mean this location plus 4, 8 mean this location plus 8. Okay, understand? And if we want to change to another location, how we do? We do like this. We just replace the value of the segment register from 2100 to the location 2300. Okay, we move. Yeah. So now the previous location is free for a new user, and now your location move to the new location 200 and 2300 here. Okay, that is the way to manage the memory location by using the segment techniques. And next one is what kind of segment register? We have the data segment, extra segment, some extra segments such as E, F, G. Okay. We also have the stack segment and code segment. Okay. The stack segment to manage the stack memory. Okay, the code segment of course for the code memories. And from the we have the segment register here, C, S, D, E, F, G. Okay, we have some segment register, and based on this segment register, we can find out the linear address value. How to find? we need to access to the segment register. Okay, this is a kind of the memory lookup, and from this value, and we look up to the segment register, and then we can get the linear crest. See the multiple for the demonstrate multiple process context switching. Okay, and normally for the segmentation techniques, we have two kind of mode: the real mode and protected mode. In the real mode, it's very easy to calculate the linear crest. We just take the segment address, we add one more zero. It means we shift 4 bit, and then we make a sum with the offset address, and we can have the full address, 20 bit linear address. How about the protected mode? This is the summary for the real mode. Okay, shift 4 bit plus offset, and we get 20 bit. For the protected mode, it's different. Yeah, we have to use the segment register in the register table, and we try to access to know where is the full address. Here, this is the table. All the information in the segment register, and we have the segment selector, and we use this table to find out the address, and then we can get the linear address. Okay. And for the protection mode, there are three kinds of protection. The first one is limit check. The second one is type check. The third one is privilege check. Let's go to the detail. Limit checking. Okay. Limit checking, you see the limit is mean we try to keep the access location inside the segment. It means cannot be outside. Why? You see, this is the example. For example, we have a location for the segment is here, here, and here. Okay. Each location have the size of 500 by, for example, 500. This is the check example value. And we have to check that when some instruction run in this location, they do not exist. Okay. Exist is mean go outside. Exist, yeah. Exist means go outside the location. If you apply jump CS 250, it's okay because inside the location. How about this? Jump CS 501 is limit. Yeah, why limit? Because for each side we have only 500. 500 is the maximum number. But we jump to the location 501. This means we got a violation. Okay, cannot. Okay, we will get error. This is the next example. When you try to move the data from the AX to this location. This location means we have two values. Segmentation is the ES. This is the offset address. Okay, this is the segment address, offset address. For the AX, we have AX is the 16-bit register. This means 2 byte. Okay, and when you copy 2 byte to this address, it's okay. Now we will go to the 498 and 489. Okay, 408. So we have the value like that, and then it's okay because 498 inside the range of 500. About this, we will get a violation because 498 is okay, no problem. But the EAX is 4 byte register. This is the 32-bit register EAX. Okay, 4 byte is mean they will contain in the address 498, 499, 500, and 501. And they are 4 byte, 4 location. Why 4 location? Because the register EAX contain 4 byte. Because they are contain 4 bytes, so we have to copy all the data to the 4 location in the sequence, okay, sequentially. So we will get a violation because 4 location 498, 499, 500, 501, and so 501 cannot be allowed. Similar case for the boost AX. Boost AX, if the stack pointer now is 498 is okay. But if you apply boost EAX, is different. EAX is the 4 byte register, and when you copy 4 byte register to the stack memory, and at that time the stack pointer is 498. It means they will store 4 byte 498, 499, 500, 501. Okay, and this is the violation because each range, each location only have the limited of 500. Pop, I think similar. Pop similar. Yeah, that is the way to manage. And next one, I will talk about the privilege level. 0 means the highest privilege level, and number 3 is the lowest privilege level. And the privilege level will assign to the segment. And you can see that some segments have the privilege level from 0 to 3. This is the summary for the limit checking. When you check the limit, effective limit, we have to consider maybe they will accept just 1 byte, or maybe they accept 1 word, or maybe they accept double word, quad word, okay, or double quad word. Yeah. So it's the first case 1 byte, is it 2 byte, is it 4 byte, is it 8 byte, is it 16 byte. For the type checking, we have to check the types in the register table, because some segment only can read, or some segment can read and write, some segment can execute. So depend on the condition, we have to check. Okay, check the bit. How can we check the S bit? I will show you here. This is the S bit. Yeah, you can check very easy. Okay, how about the privilege level? No, okay, wait. I show this slide. Yeah, this slide. So, because if we want to have some protection mode for the segmentation, and we have to define the privilege level. And if some user have privilege level more important, I mean the privilege level must less than. Okay, less than mean have more power, have the more privilege. Okay, you see where Sorry, let's I go back to the slide. This one. 0 mean highest or 3 is lowest. Okay. Zero, that is for the system kernel. Level 1, level 2 for the system service. The level number 3 for the application. This is the detailed information. So by using the privilege level, we can prevent the user from interfering with the other. Okay? And we also can apply examine the secure data, or we can try to find a bug from the damaging data. Okay. And remember, we have to set the privilege level for every process, every task, and they must have the higher privilege level to access for the segment data. Okay, that is the three kind of protection. Before go to the virtual memory, let's go back here and please check again. Any questions? Yeah. Limit check, type check, and privilege check. Okay, we have to understand three kind of checking for the protection hole. Limit check is mean we try to check the access location. Okay, we have to access some location inside the side of the segment. We cannot go outside the boundary of the segment. Number 2, type check. Some segment only can read, or only can write, or can read and write, or can execute. We have to check the type. The last one, privilege level check. Privilege level check is mean when some user or some data want to access the segment, and they have to check the privilege level. They must higher than privilege is higher for the current privilege level. Higher is mean the value is smaller. Okay? Yeah, that is for the segmentation techniques. Any questions so far? I think I can go to the next part. Virtual memories. Okay. The virtual memories. Have you heard about virtual memory? Ổ nhớ ảo. This is a very interesting topic for the operating system. And at the beginning, the engineer want to extend the RAM memory, so they propose the idea about the virtual memories. Yeah, at the beginning, they want to extend the RAM. Why they want to extend the RAM memory? Because normally the RAM is expensive, so that we cannot buy much memory for RAM. We also can buy the hard disk. The hard disk have a very large size. However, the hard disk runs slower than the RAM. Okay? And we can store all your data, necessary data, to the memory and to the hard disk. And when we want to use some value, we just copy from the hard disk, to the register. Okay, just copy. And we have a mapping between the virtual memory to the physical memories. Okay. So at the beginning, I mentioned that the idea using the virtual memory to extend the RAM. However, the virtual memory have some useful feature, such as the memory protection. It means memory protection. What does it mean? It means for each program, we can each program can just access the range of address called the address space. Okay, by using the virtual memory, we can easy to separate address space. This address space for the first process, another process space for another process. Separate, okay, because this is the virtual memories. We can easy to separate the location, and virtual memory can help to prevent program from interfering with another program, okay, with other programs. And also virtual memory can help program to cooperate or share memory. That is the three feature on the virtual memories. So you see this feature when you have the mapping from the virtual memory address to the physical memory. We have the mapping like this, and of course the size of the physical address always less than the size of the virtual address. And how we do? How can it run? Because the physical address cannot store all the data of the virtual address, so they just store a part, okay, just one part, and the remaining data will be stored in the hard disk. Okay, we have the remaining data. The data not belonging to the process will store in the hard disk. Okay. For the physical address, each page we divide into some page. Actually we call it the page frame. Each page frame can be 4 kilobyte, 8 kilobyte, or 16 kilobyte. Okay, depend on the programmer. You can set up. And, thanks to the virtual memory, we can run very big programs. Okay, maybe we can run 4 gigabyte code. Can run on 128 gigabyte. Why? Why? Because we can easy to copy. We can store some data into the physical memory, and another data, the remaining data, we store in the hard disk, okay, in the secondary memory. And we can, if we try to access some data, but that data not in the physical address, physical memories, we can copy. Can we copy from the hard disk, copy to the main memories, the RAM memories, and then we call this the pay heap. Okay, the pay heap. The pay heap is mean the data now available in the RAM. The pay for is mean if we try to contact the data, but that data not in RAM. Not in the RAM. Not in RAM. So it's located in somewhere. That's data located in the secondary memory. It means in the hard disk, and we have to copy the page from this one to another one. And this is the detail on calculate the full address. I explained already. Actually, this picture similar this. We have the mapping from the virtual memory to the physical memory. And in the physical memory, we divide to some page. Some page belong to the process. Some page not belong to the process. Okay. Any questions? So in our class, anyone heard about the virtual memories? Have you studied sub-subject about the virtual memories? Các em đã học cái môn nào hay là học đâu? Có nói về bộ nhớ ảo không?
Not yet, sir.
Not yet. Okay. I think you can read about the virtual memories in some textbook about the operating system. Okay. Operating system book. Okay. Try to find some book about the operating system. And in the operating system, you can, in the book, I think they will talk about the virtual memories. Okay, they have the operating concept. Okay, try to find out some book about the operating system, and you can get the topics virtual memories. Okay, this one about the memory management. Okay. Yeah. And next one, I will explain about the memory management. I will show you 4 cases for the memory management problem. Okay, the first case is related to the provide the memory allocation for a pointer. Before using a pointer, remember, please declare. Okay, this one. You have to declare the new location for the pointer. Okay, because the pointer is always, it just store the address, but that address must be valid. Okay, because when you declare int integer star x, it means you declare the new pointer for the integer value. Okay, however, when you declare the new one, and is there anything in this pointer? No, you just declare, and maybe they have some address, but that address cannot be used. The address stored in the x is invalid. Okay, not valid. How to make it valid? You assign a new location to the star x. Okay, the compiler will find out available location for x, and after that you can write star x assigned to some value. For example, number 5. That is the first problem. This is another example. And when you declare decryption, and you have to use instead use new, you can use malloc. Okay, that is the C style. Okay, for the C++ style, you use new. Okay, this is the memory location. When you try to use pointer, and then after using, we have to free the memory. Okay, if you do not free memory, we call that is the memory leakage. Okay, memory leakage. If you forgot to free the memories. How to free memory? For the C++ style, you use delete instruction. For the C style, you use free P. Okay. This is the example. You declare the new memory location. After using, you just free. For the C++ style, after you declare the pointer P, P1, P2, after using, you can delete P1, delete P2. How about reside? For the reside location, you can declare reallocate. Okay, reallocate. This means reallocation. For example, you declare the description. Okay, here you declare description, and then you want to change the size. At the beginning, you declare 30 character, and after that, you want to increase to 100 character. How we do? We apply reallocation. Okay, with 100 character. The last problem related to the array. Even though we know that we have to free the memory after using, but not just simple like this for the array. This is the array of the pointer. You see, star is mean 2D array. If you have 2D array, and for each member of the array, we have another array. Okay. And after using, if you delete like this, you will have a problem. Okay. And how to solve the problem? This is the solution. You have to delete every member of the array first, and after that you can delete the array. Okay, you have to delete every single member by using the for loop and delete key for every member, and after that you delete the whole array. Okay, that is the all four problem. Yeah. All the problem here I show in the class topic. I check which one. Yeah, the topic number 20. You see, the topic 20 related to the memory management. Two topics. Okay, the topic number 19 and 20 related to the memory management. And please read the slide, okay, to do class projects. Topic 20, 19, and 20. Let's check all the. Yeah, we don't have any group to select the topic 19 and 20. All the topics just from 1 to 10 to 11. Okay, so let's I ask you about project's progress. Okay. Any questions about your project progress? Is this okay? Submit the class projects.
Cái câu mà cái màu đỏ đó, cái câu đó thật ra trong trường nó chẳng nghe.
Your class is TT01.
Sau này lên các bạn khi gặp các bạn
TT01.
thật ra cho thay trường hợp cái phần cảm sát luôn thì mình cho não nhưng mà để cái xa luôn để cẩn thận thành thật là sao bên họ đồ não là không biết trên mạng và thật là sao đây thật là sao dạ cái não là không biết trên mạng và thật
là Hưng được tên là chắc.
The total 11 group.
11 group. Hàng ngày xong bạn cái đầu á thấy ảnh đúng không?
So you submit already.
Thấy cái là
Is it okay?
ảnh là gì?
Yeah, I will post the information
Cái nào đúng rồi cái đó.
for
Cái này sao không có được.
submit 100%. Okay.
Nhưng mà trong cái chiếu mà còn trên lớp mà thấy mấy thầy cô giảng còn phải chiếu không? Thấy không? Có thấy không chưa anh? Có thấy thầy cô giảng còn phải chiếu hình chưa?
Dạ rồi.
Thì cái màn đó có hình trên phải trên đó.
How about the homework? Have you submit already?
Rồi anh mà không có nhìn màn là nào? Đây cần phân biệt rõ nào để sau này lên 90 ta sẽ học lại cái này. Cho nên cái thống cái Google lớn á lại đặc biệt hơn Google lớn chỗ là nó có một trường hợp cho thầy đó là cái sai lầm cái phần sai lầm cho thầy
Nguyễn Vũ Anh Khoa, are you here? Nguyễn Vũ Anh Khoa. Nguyễn Vũ Anh Khoa. I see your name here, Nguyễn Vũ Anh Khoa.
Yes, sir.
So why you did not submit the homework? Have the schedule? Yeah, I'm not sure. Maybe in the December. Yeah, just wait. Yeah, for the new information for the final exam.
Okay, sir.